So let's continue our examination of the nomenclature of alkanes and look at some extra examples. Now we've got our basic rules down. Of course, the first step is to look for the longest continuous chain of carbons. Pretty easy in this case because it's just 4 carbons in a row. And we want to number that main chain to give the lowest possible numbering to the branches themselves. If we numbered from the left, the first branch would be on carbon 2. If we numbered from the right, the first branch would be on carbon number 3. So we're going to number the main chain from the left. And now that we've locked in the main parent chain carbons for the molecule, we want to identify those branches and where they are in the molecule. Pretty straightforward. Just a bromine, which changes to bromo, and it's on carbon number 2. And then finally we want to put the whole thing together as one continuous word. So we get 2-bromobutane. Let's try another. Something a little bit more challenging this time. Again, identify the longest continuous chain of carbons. And we've got 1, 2, 3, 4, 5 carbons again in a straight line. And the alkane based on 5 carbons is pentane. We want to number that main chain to give the branches the lowest possible numbering. If we started numbering from the left, our first branch would be on carbon 2. If we numbered from the right, the first branch would be on carbon 3. 1, 2, 3. So there's another example where the left wins. And we'll number those 5 carbons in a row. We want to identify the branches which are on the molecule. Again, still bromine, so that becomes bromo, with 2 separate ones on carbon 2 and carbon 3. So we would list them in the final molecular name as 2-bromo and 3-bromo. So putting the whole thing together, it becomes 2, 3, because we separate numbers by a comma, then a dash to separate the number and the letter, 2, 3, dibromo, the di, to tell us that there are 2 of the same kind of branches on the molecule, 2,3-dibromopentane. And it's worthwhile at this point just examining our naming system when we have multiple branches which are identical. Di for 2, tri for 3, tetra for 4, penta for 5, hexa, hepta, octa, nona, deca for 6, 7, 8, 9, 10. Just as we saw in Chemistry 151 last year. Let's look at another. Again, try something a bit more challenging. Let's look for the longest continuous chain of carbons. It's still from left to right. We want to number the carbons in that main chain, and number so that we can give the branches the lowest possible numbering. From the left, the first branch is on carbon number 4, but if we look from the right, the first branch is on carbon number 4 as well. So we then, because of this tiebreaker, look to the next branch position. From the left, we don't see the next branch until we hit carbon 5, but from the right to the left, that second branch is still on carbon number 4. These are 2 separate fluorine branches on the molecule. So the tiebreaker is to number from the right, heading to the left. 1, 2, 3, 4, 5, 6, 7, 8, an octane derivative. And we then want to identify these branches on the molecule. We've got this ethyl branch on carbon number 5 because it's 2 carbons long, based on the name for the alkane with 2 carbons. We take off the A and E ending to the name and change it to YL. YL endings represents a branch rather than the parent chain, and there's only 2 carbons in this branch because the carbon at the front here is part of the main chain. carbons can't be part of the parent chain and the side chain at the same time. So 5-ethyl, and then with fluorine atoms on carbon number 4, we change the name ending to O by taking off the INE, so it becomes 4-fluoro, or 4-fluoro, I should say correctly. And then put the whole thing together to give us a name. It becomes 5-ethyl 4,4-difluoro, because there's two of them, octane. Also notice, as we mentioned before, the prefixes, the branches, are listed in alphabetical order, so E for ethyl before F for fluoro, rather than numerical order. But that doesn't change their numerical position on the parent chain. Next one, and our last one for this video, a little bit more challenging again. Look for the longest continuous chain of carbons, and that's still basically horizontally across the molecule from left to right. This is going to be carbon number 1, because when we look at the molecule, our first branch would be on carbon number 2 here. If we numbered from the right, our first branch wouldn't be until carbon number 5. So the left hand side wins again. Let's lock in those branches. So we've got a methyl group from methane on carbon number 2, but just note that we've actually got two of them together on carbon number 2, and we also have that propyl branch on carbon number 6. 1, 2, 3 carbons long, but we don't include the carbon at the root because that's part of the parent core chain. So putting this all together, we are going to name it as 2,2-dimethyl, M for methyl before P for propyl, 2,2-dimethyl 6-propyl decane.